So Tony, please, your thoughts and announce our first Distinguished Design Award.
Thanks, Don, and thank you to my co-judges. Thanks, Jill, for that incredible preamble. So an award for distinguished design, urban planning, and a 7,000 US dollar prize goes to, wait for it, Team Jellyfish for their submission, Imagine a Seaweed City. Team Jellyfish is composed of 6 students from the Gerald Hines College of Architecture and Design at the University of Houston in the United States. The team is led by Ian Cole, with co-members Tran, Lucia Poggioli, Jailyn Benavides, Leslie Alamirra, and Lauren Smith. In design and urban planning, ESG goals, decarbonization targets, and policies are increasing the demand for adaptive reuse and transformation of buildings into high-performing assets and at much lower carbon costs. Not only did Team Jellyfish lean into this concept in their competition entry, but they took on the challenge of imagining a redevelopment plan for Houston Northside. Quite an ambitious plan that strives for net zero with regards to energy, water, and waste. Let's take a look at their video.
Imagine a seaweed city. The Northside neighborhood in Houston, Texas, is a community of collective remnants. Originally, Houston's oil and petroleum industry supported the community and helped it prosper during peak years of infrastructural advancements. But now, the gravitating pull of this leftover industry hollowed out and litters the site with brownfields. These are the lasting effects of industries, not uncommon in Houston's industrial-based history. Houston may be one of the fastest-growing global metropolises, home to a talented workforce that offers tremendous opportunities for companies and individuals to thrive. Yet the demand for equity remains high, and the growth trajectories of our industrial-based economy have resulted in a downward trend of jobs in our area. Our commitment is to the future of Northside residents with Houston's economy at stake. We are looking to put the future of the community as the new frontrunners of an emerging energy biofuel industry, to bring about a new wave of growth and prosperity that originally encompassed the efforts of the humble labor movement, that tackles the issues of greenhouse gases from just the energy production of emerging advanced algae bioreactor technologies. With a huge commitment to harvesting water to address the overlying issues of Houston's flooding environment, water is also considered a crucial resource in proliferating algae reproduction. We include community gardens in our proposal to encourage an urban food security, allowing citizens to grow their own food or donate what they have grown. The overall site's opportunity zones from leftover industrial unused brownfields far exceed the amount of land into making this a reality. We are pleased to present our master plan that features energy-efficient buildings with the remaining left retrofitted or adaptive reuse in a community of hardworking blue-collar families. The high-efficiency building stock is based on reducing energy overall demand by 60% versus baselines. Additionally, we aim for a healthy walk-first community. Our mobility will be switching to biofuels and to a more energy-efficient technology to facilitate a walkable and transit-friendly community by electrifying the fleet, vehicles, and based on that, reducing overall energy demand for transportation by 70%, making up the balance made up by renewables for net zero energy. Energy-efficient buildings, with roof coverage of solar panels and through the grid, excess energy can be sent to other nearby buildings. Algae production takes a commitment to harvesting water. Water including wastewater is collected, filtered, and placed in photobioreactors and raceways. Through the photobioreactors, the algae temperature is able to be regulated so they do not get overheated in the summer and die. In addition to the CO2 and sunlight, wastewater provides the nutrients for the algae to thrive at a higher concentration and grow at a faster rate. Bioreactors wrap around buildings. Photobioreactor pipes are around 1 inch in diameter and they are regulated like the panels. They wrap around the buildings but are placed over the facade, while panels are the face of the south side of the buildings. Overall, 1 kilogram of algae is able to absorb 1.8 kilograms of CO2 from the atmosphere. Imagine a seaweed city. Thank you.